Hello all, my name is Pallavi Wankhede and today I am going to explain you about two clustering algorithms, that is k-means clustering and hierarchical clustering. So firstly I am going to explain you that what is meant by supervised and unsupervised learning. Then we will talk about clustering. Then I'll explain you two clustering algorithms in detail, and then I'm going to explain you the comparison between these two algorithms. So, supervised learning is the machine learning task of learning a function from labeled training data, while unsupervised learning is the machine learning task of inferring a function to describe hidden structure from unlabeled data. So, mainly, supervised learning algorithm needs labeled training data, while unsupervised learning needs unlabeled data. In labeled data, we need input as well as the output, while in unsupervised learning, we just need the input and the machine itself finds the hidden structure in the data. So, the difference between both is that input data is labeled in supervised learning and input data is unlabeled in unsupervised learning. Supervised learning uses training data set while unsupervised learning just uses the input data set. Supervised learning is used for prediction, whereas unsupervised learning is used for analysis. Supervised learning is classified into classification and regression, while unsupervised learning is classified in clustering, density estimation, and dimensionality reduction. Now here is the chart giving the classification of machine learning into two types. So machine learning is divided into supervised learning and unsupervised learning. Then supervised learning is classified into two types, that is classification and regression, and unsupervised learning is classified into one type, that is clustering. These are the algorithms based on classification, regression, and clustering. In this session, I'm going to explain you about the two algorithms based on clustering, that is k-means clustering and hierarchical clustering. So firstly, we will understand what is meant by clustering. So data clustering is an unsupervised learning problem. For example, if we have given an unlabeled examples from x1 to xn and the number of partitions are k, so our goal is to group the examples into k partitions. So if this is the input data, then the desired clustering output must look like this. See, these are the clusters over here. Now, the only information clustering uses is the similarity between examples. The question here is, how does clustering works? So, clustering is based upon the similarity. If the features have same similarity, so that features will be grouped into one cluster. Now, clustering groups examples are based on their mutual similarities, as I said. Now, what is a good cluster? So, good cluster has two main things. First is it is high within cluster similarity and it has low intercluster similarity. Now, we will see the clustering similarity between data points. So, how to find the distances? So, here choice of the similarity measure is very important for clustering, right? And similarity is inversely related to data. Yes. See, if we have more similarity, the distance between the data will be less, and if we have more distance, the similarity of the data will be low, right? And now we will see the different ways that exist to measure data. So here we have three methods to measure the data. First one is Euclidean distance, second one is Manhattan distance, and third one is kernelized nonlinear distance. So Euclidean distance formula is over here, Manhattan distance is this, and kernelized distance is this. Now here we have two examples given over here in the graph. So the first figure which is shown here, in this figure, which distance will be more preferable? So here, as the data is so dense, so it will be very better if we use Euclidean distance, because Euclidean distance may be reasonable because we can find the distance between dense data very easily. And here the distance between the data is too far, so here it will be better if we use kernelized nonlinear distance. Now, here I'll talk about the types of clustering. So we have mainly two types of clustering: flat or partitional clustering and hierarchical clustering. So partitions are independent of each other in flat or partitional clustering. See over here we can see No cluster is dependent or interrelated on each other. Each cluster is different. Here yellow, green, red, pink, blue, Persian blue, right? And the examples of flat or partitioning clustering are k-means, Gaussian mixture models, etc. So we are going to learn about k-means cluster further. And in hierarchical clustering, we have two types, agglomerative clustering and divisive clustering. We are going to learn about this both clustering types further in detail. And in this hierarchical clustering, partitions can be visualized using a tree structure, that is a dendrogram, and we are going to see it also in further session. Now, firstly, we will understand what is meant by k-means clustering. So, k-means clustering is a type of unsupervised learning which is used when you have unlabeled data, that is, data without defined categories or groups. The goal of this algorithm is to find groups in the data with the number of groups represented by the variable k. So here k is the number of clusters we are going to use to find the clusters. The algorithm works iteratively to assign each data point to one of k groups based on the features that are provided. So this algorithm is an iterative algorithm until we find the best clusters in our data. The data points are clustered based on feature similarity, that is distance. In k-means clustering, we use mainly Euclidean distance to find the distance between the data. Now, the k-means clustering algorithm inputs are the number of clusters k and dataset. The dataset is a collection of features for each data point. The algorithm starts with the initial estimates for the k centroids, which can be either be randomly or selected from the dataset. So firstly, we have to select with our own any cluster number of clusters, and then based on that we find the mean and then we find the best clusters. The process of k-means clustering, now we will understand the steps. The first step is to set the number of cluster k. So this is by our own. We have to choose the number of clusters by our own in the first step. So we can take it out for 2, 3, 4, anything based on our own choice. And then second step is the algorithm then iterates between following two steps until no more change in the centroid point. So now these two steps are going to repeat it until we get the best clusters. So the first step is data assignment step and centroid update step. So firstly we will learn about the data assignment step. So in data assignment step, each centroid defines one of the clusters. Yeah, right. See, each cluster has some data and each cluster must be containing the data which is not part of the other cluster. Each and every cluster must be separated, right? And now in this step, each data point is assigned to its nearest centroid based on the Euclidean distance. Notate over here, we always use Euclidean distance in k-means clustering for better results. The formula is given over here. Here k means the number of clusters k, then ci means the ith cluster, x means the data point in cluster, and d is the standard L2 Euclidean distance. See, now here you will understand very cleanly about the k-means clustering. The visualization I have provided you is very good. So first one is the data assignment step. Now here, firstly randomly set a point as centroid point. So this is the example. In this graph, we have 10 points. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now between these 10 points, we have to take two clusters by our own. We have assumed that we are taking k as 2. So for example, we have taken this as the first cluster and this as the second cluster. So the first cluster centroid in the cluster is at 2, 1, and the second cluster we have assumed is at 3, 3. Now see, you can visualize over here. So this 1, 2, 3, 4, 5, 6 points are in the second cluster in this red line, and the first 4 points, that is 1, 2, 3, 4 with the centroid this is in the cluster 1. Now see, in this step the centroid, now we'll learn about the centroid update step. In this step the centroids are recomputed by taking the mean of all data points assigned to that centroid's cluster. Now form like this table, and in the first, see, these 4 points 1, 2, 3, 4 are given here over here, and the 6 points remaining in the cluster 2 are over here, right? So this is cluster 1 and this is cluster 2. Now for the new centroid point, we have to take the mean of the x values of the first 4. See here, 1 plus 2, 1 plus 2, and the second y points to 1 plus 1 plus 2 plus 2 divided by 4. We have to take the mean over here and we get the new centroid point, that is 1.5, 1.5. Similarly, for the second cluster, we have to take the mean of all this 6 data and we get the new centroid at 5.1 and 5.6. See, we got the new centroid and the data index is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, firstly, we had that new cluster centroid at this and this, but now our second new centroids are over here and over here. Now the problem over here is that this point which is there, it is in both the clusters, in cluster 1 and cluster 2, and it is not good. So we have to either put this data point over here or over here. So for this we have to again repeat the data assignment step once again. Once again we will count the means for this points, and find the new centroid. See. Now earlier we had only 4 points, now we have 5 points because this new centroid is added over here, and we have 6 points over here. So so we will find the mean. So we get 1.8 and 1.6 as our new centroid for cluster 1 and 5.6 and 6.2 the second centroid for our cluster 2. Now we can clearly see that no point is outside and no point is mixing between the two clusters. We got our 6 points in the cluster 2 very clearly and 4 points in the cluster 1 very clearly. So as we got very clean clusters both, here we can stop our data assignment step and the iteration and we get our clusters. In this way we have done the clustering for the previous example. I hope you have understood it very cleanly. Now repeat data assignment step and centroid update step till no more changes of centroid point. Here no changes are required, so now we will stop our algorithm. Now advantages of k-means clustering are the algorithm is simple to use and the algorithm can guarantee the result. Right, and disadvantage of k-means clustering are need to specify k the number of clusters. Right, we have to firstly by our own specify the number of clusters, and then often terminates at a local optimum, not suitable to discover clusters with non-convex shapes and not suitable to discover clusters with different densities. Right. Now I will explain you about hierarchical clustering, what is meant by hierarchical clustering, and then we will learn the 2 Python codes based on k-means clustering and hierarchical clustering. So now hierarchical clustering, this is known as dendrogram and this is the Venn diagram of clustered data. Now hierarchical clustering. So as earlier we have learned that hierarchical clustering are of 2 types, that is agglomerative hierarchical clustering and divisive hierarchical clustering. These both are actually opposite to each other. See, hierarchical clustering is what? It starts with n clusters, one for each object. At every step 2 clusters are merged into one. See, at each step 2 clusters are merged into one, and finally we get only one cluster. And in divisive hierarchical clustering, it starts with one cluster containing all objects, and then at every step a cluster is split into 2. So these both are opposite. This forms at the end one cluster, and this starts from one cluster, and then it's divided into many clusters. Now different types of linkages we have single linkage, complete linkage, average linkage, and average group linkage. Now hierarchical clustering, we will see the steps in agglomerative hierarchical clustering. So first step is initialization. Each object forms one cluster, then 2 more similar clusters are grouped together to form a new cluster, and then calculate the similarity between the new cluster and all the remaining clusters. And this is also iterative algorithm until we find the best clusters. Now, hierarchical clustering. Now, the question is merge which pair of clusters? See, we have many clusters, but which to pair together? That's the question. So now, the distance of two objects is obvious. It is defined by distance measures of our choice. But what about the distance between two clusters? So let's see the answer. So now for that we have four linkages as I said. First one is single linkage, that is nearest neighbor. Here the distance between two clusters, that is equal to minimum distance between the members of two clusters. Means from cluster 1 which one is closer to cluster 2, and from cluster 2 which member is closer to cluster 1, that distance is taken and then we form the chains. Now in complete linkage, the maximum distance is taken. Right, in single linkage we take the minimum distance, in complete linkage we take the maximum distance between the members of two clusters. See over here we have taken the maximum distance. In average linkage we take the mean distance between all pairs of objects of the two clusters. Right, the advantage of taking this average linkage is that robust to outliers. And then lastly, we have average group linkage. Here, the distance between two clusters is equal to the distance between the means of two clusters. In the cluster 1, the mean of the distances is taken and found, and similarly in cluster 2, mean is taken and that distance is taken into account, right? Now, in hierarchical clustering, we have example nearest neighbor algorithm. See, nearest neighbor algorithm is an agglomerative approach, that is bottom up. It starts with n nodes, that is n is the size of our sample, merges the two most similar nodes at each step and stops when the desired number of clusters is reached. So based on the similarities, it goes on merging the clusters into one. See here example. See now here, firstly we have 8 clusters, 1, 2, 3, 4, 5, 6, 7, 8, and x6 and x7 are similar. So we have merged them into one and now we got 7 clusters, 1, 2, 3, 4, 5, 6, 7. Now similarly x2 and x3 are similar, so we merge them into one. Now we got only 6 clusters, that is 1, 2, 3, 4, 5 and last is 6. Again, the x and 4 are similar, so now we got 1, 2, 3, 4, 5 clusters. Then now we merged these two because they were similar, so now we have only 1, 2, 3 and 4 clusters. Now we have only 3 clusters, then 2, and lastly we merge these 8 clusters into 1. So this is called as agglomerative hierarchical clustering. Now we will lastly see the difference between both, that is k-means clustering versus hierarchical clustering. K-means clustering produces a single partitioning, right, and hierarchical clustering can give different partitionings depending on the level of resolution we are looking at. K-means clustering needs the number of clusters to be specified and hierarchical clustering doesn't need the number of clusters to be specified, right? In k-means clustering we have to assume at the start the number of clusters by our own. In hierarchical clustering there is no need for any assumption. Based on the similarity of the cluster they are merged into one. K-means clustering is usually more efficient runtime wise, and hierarchical clustering can be slow because it has to merge several clusters into one based on their similarity, so it takes times. In k-means clustering we just have to define the number of clusters and it works, and no clear consensus on which of the two produces better clustering. Yeah, right, so they both clustering algorithms are different and they are best in their own ways. We can't compare between them both. Okay, thank you. So this was my presentation on the k-means clustering and hierarchical clustering. Now I will explain you the Python codes based on the k-means clustering and hierarchical clustering.